going between logarithmic and exponential form.
Super handy.
I mean, super is not even close to.
Super duper.
I mean, pretty friggin' handy.
Because sometimes it's more useful to have something as a logarithm, and sometimes it's more helpful to have it in exponential form. And in either case, you always want to start with the base, wherever it is, and then go in a circle. For example, if you're doing y equals log base b of x, you start with the base, and then you go in a circle. That's not where I meant to draw that to. B to the y equals x.
And remember, a logarithm is equal to its exponent, so that should help you organize a little bit what's going on.
Right. So if we're trying to evaluate logarithmic expressions without using a calculator, on each of these we need to set it equal to some variable. That's going to help us out, right?
Yes, I agree.
And then you can think of this without actually like literally rewriting it, but I like to rewrite it.
I do too, because I can in my mind work out 6 to what power equals 1 a lot better than I can work out log base 6 1 equals.
Right. So we start with the base, which is 6. We go around and say it's 6 to the x equals 1. A little circular fashion here. Always start with the base. Okay, so 6 to what power equals 1?
X would have to be 0 in that case.
It would. Anything to the 0 power is 1.
Yay!
All right, so let's see what else they can throw at us. Here we have equals
3
x.
to the x equals 81.
So 3 to what power is 81?
3.
No.
4.
Yes. 3 to the 4th power is 81.
Dang it.
Okay, how would you go about figuring that out if you didn't know?
Well, if you didn't know, what you could do is just ask yourself, what's the square root of 81?
You could, and you get 9.
Yeah, what's the square root of 9?
3.
And how many 9s do we have?
2.
So 3 times 3 times 3 times 3?
Okay. Another option is you could just trial and error. 3 to the first, 3 squared, 3 to the third, until you come up with it, because these are growing exponentially, right? They're growing exponentially.
They're growing
We have to have something happen between like 1 and 10 probably. Right. Pretty sure. Okay, so this is log, and this does not have a base.
That's a base 10.
Okay, so let's make it equal x. So this is 10 to what power equals the cube root of 10.
Can we rewrite cube root of 10?
Let's do that.
That's 10 to the 1/3.
10 to the 1/3.
Oh my heavens to Metsies. I know what x is.
Yeah?
That's 1/3.
Because there's this property that if these are the same, these bases, their exponents have to equal each other.
So
x equals
chitty
1/3.
chitty bang bang, 1/3.
Does that look like a 3? I don't think
is that
looks like
what
a
was
3.
that? Was that a snowman?
Did it? In honor of our most recent ice storm
Do you
in
want to
March.
build a snowman?
Well, it's
Or ride our bikes around the hall? Oh, you haven't seen Frozen, so never mind. Forget I said that.
I've watched Gravity last
Let me
night.
not rub that in that you haven't seen it yet. So
Yes.
remember, this is like log with a base of e to the third.
E to the 3rd.
So if we rewrite this, this is e to the x equals e to the third. So again, the bases are equal.
Bases are equal.
So your computer is tripping on me.
I don't know why you all of a sudden can't write good.
I don't know why you can't speak English good.
I mean, that's why I teach math, K. Steve, Mrs. K. Steve.
Yeah, you do. Okay, so this is log base e.
Oh my, that's...
What if we mess with this?
Can we
right
mess
now?
with that?
Can
Let's
we
mess
mess
with
with
that.
it?
Let's
Okay.
make it negative 1/4.
Okay. So you're saying it's e to the negative 1/4,
Yes,
right?
that's what I
say.
say.
So let's go back in slow-mo.
Okay, slow-mo it down.
So what we have is 1 over e to the 1/4.
Right, because the 4th root of
That's
is 1/4 power,
yeah, and then we move it up to the top.
which means that the exponent goes from positive to negative.
Right. So in slow-mo, that's what just happened. So that's equaling x, and we do
E to the x
e to the x.
equals e to the negative 1/4. I happen to know what x is.
Yeah,
17.
negative 1/4.
That's what I said.
Yeah. Awesome.
Okay, good stuff. Good stuff there.